From what is commonly taught, cellular aging is often described as a problem of genes, proteins, or metabolic pathways gradually failing over time. In that view, improving metabolism means pushing cells to burn fuel more efficiently or switch between energy sources more quickly. However, from an alternative theoretical perspective, metabolic flexibility is not the primary cause of cellular resilience. It is a visible outcome of something deeper, the condition of the cellular internal environment. A living cell is not merely a chemical reactor. It is a self-organizing system embedded in a highly structured internal milieu. This milieu includes water organization, ionic gradients, semi-flexible proteins, and subtle electromagnetic ordering. Together, these elements form the context in which metabolism operates. When this internal environment remains coherent, the cell can adapt its metabolic strategy with ease. It can choose when to rely on glucose, when to oxidize fats, and when to enter low-energy maintenance states. In this case, metabolic flexibility appears naturally, without being forced. As cells age, the problem does not begin with missing enzymes or faulty genetic instructions. The deeper issue is the gradual loss of internal coherence. Water structure degrades, ionic signaling becomes noisy, and proteins lose their adaptive flexibility. Once this happens, metabolism becomes rigid. The cell can no longer respond intelligently, even if all the necessary molecular components are still present. From this viewpoint, interventions aimed solely at stimulating metabolism address the symptom, not the cause. Certain biologically derived substances, especially those originating from living plants, appear to interact with cells in a fundamentally different way than synthetic compounds. Their value does not lie in isolated chemical ingredients, but in their complex, non-reducible biological organization. Such substances seem to support the internal environment of the cell rather than override it. When the internal milieu is stabilized, cells regain their capacity for self-regulation. Metabolic flexibility re-emerges as a consequence, not as a command. So, can metabolic flexibility slow down cellular decline? Yes, but only when it reflects a deeper restoration of the cellular internal environment. Without that foundation, metabolic flexibility cannot be sustained. With it, the cell does not need to be instructed. It remembers how to adapt on its own. This suggests that the future of cellular longevity may depend less on controlling biochemical pathways, and more on restoring the conditions that allow life to organize itself intelligently.